Alright, so a few people asked about number 7. So we got a projectile is fired with an initial velocity of 95 meters per second at an angle of 50 degrees. After 5 seconds, it strikes the top of a hill. What is the elevation of the hill above the firing? So one of the things we want to do is draw a picture. So we've got this thing, let's see, it's being fired, and then it's going to strike the top of the hill. Let's say the hill looks, I don't know, something like that. We don't know exactly what it looks like, but we'll go with that. Draw your initial velocity vector here, and this will be ground level like that. And write on it what we know. We know that this is 95 meters per second. We know that the angle is 50 degrees. So make your triangle so we can figure out what the initial x and y velocities are. So 95 is that side of the triangle. This is going to be 50. And then this is your velocity in the y direction. This is your velocity in the x direction. So we're taking this velocity that's at an angle and we're dividing up into two different directions, an x component to that velocity and a y component. And we know that from other examples we've done that if we just take 95 times the sine of 50, we get the y direction, velocity in the y. If we take 95 times the cosine of 50, we get the velocity in the x direction. So make sure your calculator's in degree mode. Go ahead and punch that in now. 95 sine 50, 95 cosine 50. And when I do that is the sine direction here, it's going to be 72.8, and this is in meters per second. Just can't fit it in there now. The other one's going to be 61.1 meters per second. That's your velocity in the x direction. And it should make sense that our velocity right here in the y direction is larger than the x because this angle is larger than 45. So we should have more velocity going in the y direction. So what we're going to start doing now is we're going to start listing out what are our knowns and our unknowns in this problem. So I know right here that, see, I've got x and y, and we could do initial in the x, initial in the y. This is velocity. We've got final x velocity, final y velocity, and I'm just going to write these out every problem we do like this. Sometimes we care about the y's final velocity, sometimes we don't, but it's just kind of nice to see everything laid out for us here. Delta x, delta y, and then we've got delta t. So I know that the acceleration in the x direction is 0 meters per second squared because the velocity does not change. We're using negative 10 for the acceleration in the y direction. What else do we know here? Let's go back to the problem. We now know the VIX and the VIY. So we got 61.1 meters per second, and then our VIY was 72.8. The final x is going to be 61.1 as well because once again it doesn't change. What else do we know? Do we know anything about delta x or anything like that? We don't. So now we've got to figure it out from there on. So if I'm looking at this, I got to go, okay, how are we going to solve for delta t, delta x, and so forth? If I know delta t, then I can multiply it by our velocity in the x direction. That will give me delta x. So let's see how we can solve for delta t just using what we know about the acceleration and the initial y velocity here. So this is what we want to know is how long is it in the air? Right here. So look at our equations here. We know initial velocity, we know acceleration in the y direction, we don't know final velocity. So the final velocity in the y gets knocked out right here. But one thing we didn't mention was we do know delta t. That's one thing I meant to put that in here. Most of the time we don't know delta t. We know delta t this time, 5 seconds. That makes the problem a little bit easier to do, doesn't it? So looking at this, I do know delta t, as I was saying a second ago, so I can just say delta t, which is 5 seconds, times how fast I'm going, 61.1 meters per second in the x direction, will give me how far I go in the x direction. So 5 times 61.1 is equal to 305.5. So that's my delta x. And this is in meters. That answers, let's see here, what is the horizontal distance? That's 305.5 meters. That's one answer. Now the next thing is, how high does it go? What is our delta y right here? Now looking at this equation, let's see, we got everything we need in this equation right here. So you have delta y, that's unknown, is equal to your initial y velocity. The initial y velocity was 72.8 times delta t of 5 seconds plus 1/2 times -10 times 5 squared. So we're going to punch all that mess into the calculator. Let's see, here we got and I get 239. I'll double check that. And yep, that looks like that works out. So this should be your delta y right here. 239. So what is the elevation of the hill? That one's 239. I went through that one a little bit faster. If that was too fast, you can let me know. I'll go over it in class. But those are your two answers. This is your delta x. This is your delta y. If you want, you can also look at some of the other videos. I go through those a little bit slower, but that's it for this one.